right, so number two. Number two says, for those of you who want a little bit of help with this, it says create a table of values for each function for values near its non-permissible value. Explain how your table shows whether a point of discontinuity or an asymptote occurs in each case. So what you want to remember is what we talked about before. A gap discontinuity would look something like this. A curve or a line that would have an open space where the x value that is restricted causes an undetermined or undefined value for y, but that the graph on either side are very, very close together. You see, the points are very, very close together. A jump discontinuity or something like that would look like this. The graph here, and then here's your undefined value, but then the graph picks up over here somewhere, you see? So it's a big jump. So what this question is asking you is, find out what these y values are just before the unrestricted or the restricted value, and find out what they are just after. If those values are all really close, it's just a gap. If they're not close, it could be a jump, or in many of our cases, what we're talking about is a vertical asymptote, right? So if you have a very large positive value on one side of the restricted value and then a very large negative value on the other side, you know it's an asymptote. So it's either asymptote or a gap. Where does it say? To a point of discontinuity, like a gap. That's what we call a gap here.
How do you solve for how do you find the point of discontinuity?
Well, okay, finding the point of discontinuity is pretty easy. That's what we did yesterday. You're just finding restricted values.
Yeah.
So in A, what's a restricted value for x? What can x not equal?
0.
Yeah. So what you do is you set the denominator equal to 0, and if there are multiple factors, you set each factor equal to 0 and solve for the x, because those are the value or values that will be undefined. So here x cannot equal 0 because that would make this denominator 0. So we have a restricted value at 0. I'll just do a real quick sketch. At 0, we either are going to have a gap, a point of discontinuity, or an asymptote. So let's check x equals like negative 0.01 and x equals positive 0.01. Those are values that are very, very close to 0, but one is on one side of 0 and one is on the other side. So a table of values would you would literally say this. For the y value, you would say, okay, what does negative 0.01 squared minus 3 times negative 0.01 divided by negative 0.01, what does this give us? And you'd literally just evaluate this and find out what that answer is. And then you do the same thing for this other value, right? You do the same thing and then find out what that equals. So go ahead and do that on your calculator, and that's literally what you're doing.
So you don't factor it once?
No, we're not. No, you don't have to factor it first at all, because it's just asking you to explore using a table of values what the values are on either side of the value, so that you can determine whether it's just a point discontinuity. So it could be something like this. That's just a point or a gap discontinuity, or it could be something like this, right, where you have an asymptote. So that's what we're trying to find out. So go ahead and do this, and then we'll do that on our calculators and find out what these two values are, and then we'll decide. So that's what you do for A. Go ahead and do that. Okay, so I got values that look like this from my table of values. For this one, I got negative 3.01. And then for the positive one, just on the other side, I got negative 2.99. These values are extremely close to one another, right? So it seems like just on either side of this restricted x value, I have literally almost the same value. So that looks like it's just a point discontinuity. It's just a gap, not an asymptote, okay? So I graphed it over here too, and here's what the overall graph looks like. And at 0, okay, look at it's undefined. So if I zoom in there, it does appear that on the left side, it's negative 3.0, 1 or whatever, okay? And then the y value, the y value is negative 3.01, and on the right side, the y value is negative 2.99, so it shows that it's just a gap. And that's how you do number 2. So you do the same thing for the other ones. You don't have to factor. You just put in 2 values on either side of the restricted value and see. So for example, for B, let's just see really quickly. That's negative minus 5 and plus 2. Minus 5 plus 2. Okay. So there's should have a vertical asymptote at 2. Okay. So what that means is you're going to have something that looks like this, where just on this side of the restricted value, you're going to have a large positive value. Maybe on this side, it's going to be a large negative value. If that happens, then you have a vertical asymptote.
So then which values would you use for B?
For B? Okay, well, your restricted value for B is x cannot equal positive 2. So you'd use 1.99, let's say, and then 2.01. So just a point, just on either side, but very, very close. Okay? So, yeah, you can do B. I'll show you what B looks like here too. But I'll give you a chance to calculate that first.
So I calculated it.
So if you do this calculation just on either side of positive 2, you get a large positive number on one side, just like we predicted up here, and then a large negative number on the other side. So that is what tells you it's an asymptote there. Okay?
Is there next one?
Mm-hmm.
Whichever